Everybody, welcome to Handmade Hero Show. We code a complete game live on stream. We did the work necessary yesterday to remember whether or not files have changed. So we basically snap the file date on files and then we can check them later to see if they've changed. What we need to do today is do something meaningful when they do change. We already wrote the PNG reader, so we can load them, but we don't actually know what to do with them. And so our job today is to do something with them. Sure, we can call the PNG reader, but what do we do once we get the PNG back? So I'm going to go ahead and load up Handmade Asset. That's where this is taking place. Let's just get that going here. So what you can see here is we left a stub function here called update asset package from PNG. And the thing that we created was this check for art changes. This goes through, looks to see what files the platform layer reports there being of type PNG. And after it's done with that, it looks through them all to see which ones have changed from the last time we saw them. Those ones that have changed get this called, but this doesn't do anything. It's all set up to do something. It's got the contents of the file right here. It's got an arena that it can use for temporary work, such as loading the file. And you can see that we're all set up here to go ahead and call like parse PNG, for example. But we don't actually know what we're going to do with it. So that's kind of what we need to start doing today. And again, that starts to get us into the zone that we don't really know what we want to do, which is the tags part of things. And so that's what we're going to kind of run up into today, I think. So we'll kind of run up into that and we'll stop there. And then we'll pick that up the next weekend we're coding. We'll start to take a look at what we want to do with that tag stuff. So we know that we can call the PNG reader that we wrote, and we know that it will return us an image. So this is the raw image that would come back here. We give it a temp arena. And then what we need to do is pass it a file. And we also need to have some kind of an info stream if we care. Now, one of the things that I'm pretty sure that we did, and if we didn't do, we need to do it right now. But one of the things that we need to do is make sure that we do not record anything if we don't have a destination stream. So we did not do that. So exactly what I said we needed to do, we didn't do. We want to do this, right? Because we want to be able to just not capture information to come back. And so, for example, in this case, we don't care about the debug printout that's going to happen here in the info stream. We just don't care about that at all. So what we would rather do is only initialize the error stream. So what we can do here is we want to create one of these file buffers. And if you go back and look at what we did in test PNG, we had like an error stream. You can see right here. When we do read entire file, we sort of create one of these and blah, 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 right? But what we would like to do, if possible, is we'd like to make this a little bit more systemic, because this is going to be something now that we actually do perhaps more regularly, creating one of these streams, one of these these stream things. So what I'd like to do is say, well, okay, so maybe we have a count and a data pointer or something like this. And maybe when we get to the end here, maybe we do something like stream result. We do make stream or something like this. And we pass it the count and the data and the error buffer. And then off we go. So that we know that we've got some way of making these that's reliable and that works, right? So this would be nice. Now, the problem that we have here is that the error stream, we actually wanted to use it here, right? So what we kind of want to do instead is, it's a little bit uglier, but if we want to do it that way, we kind of don't have a choice. Basically, if we weren't able to get a pointer here, we produce an error, right? So we can still kind of do it. It's still fine. It's not quite as nice. So maybe that isn't the greatest thing to do. I don't know. But there you go. So it would look something like this. And oops. that would sort of allow us to do this kind of a thing here. Right? So I don't know if that's necessarily better, but at least it has sort of a centralized way of calling make stream. You know what I'm saying? And so that we can use in other cases. And furthermore, this right here is a buffer. So we can actually sort of make this even more straightforward by doing this sort of thing. And then we just do this, right? So make a stream out of a buffer and some other stream that captures errors, like so. And that's all we do, right? So from here, if I wanted to do that, it's pretty straightforward as well. I know that I've got the contents that I want to pass through here, so I can make my file stream by just saying, hey, make a stream with these contents and whatever we want our error stream to be. Now, I do actually want an error stream here. I want a thing that will record what the errors actually were. And I think I kind of want that to be part of the asset system permanently. I don't mind that it kind of just builds up memory forever, because I think I kind of just want to be able to go back and inspect that. So what I think I want to do is kind of say that asset source files, when they get, kind of pushed onto the, I don't know what you want to call it, when an asset source file, when we become aware of it, I would like to sort of create in here a stream that is for all of the errors that are going to be associated with that source file. We'll see a little bit more about why I want to do that when we move further down the pipeline. But basically what I want to be able to do is I want to be able to tell the user when there is an error. I want to say, here's the source files that you just tried to import, and here are the errors per source file that are relevant, so that the artist can know that something bad happened or whatever. So I'm going to go ahead and make one of these a little earlier on in the pipe, and I'm going to pass that here, so we basically have when the asset source file itself is operational, it'll have an error stream, and all of the errors that happen on this file will go into that stream, not some, not off into the ether somewhere. So, I guess we'll put the thing that loads the images out of the asset file here, but for the moment, I'd like to ping pong back down to where we create one of these match structures. You can see us making one here. What I'd like to do there is go back to the stream start of things and kind of take a look at this. I want an on-demand memory stream for these errors, and I don't really care how they're being allocated, because like I said, it's never going to be freed, and it's only for development purposes anyway. So what I pretty much want to do is say, okay, in the case where we create a new match, I want to take the error stream and I want to just make that a new stream that can capture errors using the same memory that we use to store the permanent information for the asset store. So it stays around forever. We'll always be able to go back and see all the errors on a particular loaded thing for this run. We're probably not going to save them out to disk because we don't care about them further down the line, but for the most part, that's what we're going to do. Now, errors on this stream, there are none. We don't capture errors on the stream itself. If that happens, then you're just SOL. There isn't a central error stream, but that's how that's going to go. Now, we could choose to do this differently. If it turns out when we actually go to play with this, that what we'd rather have is just a single error stream on the assets, we can just put one of those on the asset system itself and vector everyone towards that stream. Again, one of the really nice things about doing the stream stuff this way is you can just revector whoever's errors you want to wherever you want, and it doesn't really matter. So we'll have plenty of flexibility to, look at that sort of stuff later, right? All right. So if we go ahead and go from here, we just need to make sure we've got, what's going on here, buffer count. We just got to make sure that we've got our make stream, which I said I wanted, but we didn't actually implement. I'm going to make one of these here. What I can do is also kind of piggyback these two since they are the same. You can kind of see you have an on-demand memory stream here and a make stream here. They're pretty similar stuff, right? So we might be able to kind of share a little bit there. I don't know. We'll see in a second. So let's take a look. When we do this make stream and we're going to pass it a buffer, this is sort of a read stream. You know, we could say make read stream here because that's really what this is doing. So if I want to do one of those, I know that we look and we kind of see what's going on here. We don't have memory. We do have errors, right? They're giving us one of those. I suppose I should put buffer here. And so then we've got, you know, contents and the bit count, bit buff, underflowed, first, last. All of this stuff can stay 0. It's really just this that we need to initialize, right? Now you'll note there's something very subtle going on here, and I'll point it out. Do you notice how we did not... So one way you could have done this, rather than having buffer contents in the stream itself, is you could have exclusively used stream chunks, right? You could have had it so that what a stream does is it always looks at its first stream chunk for the data, okay? You could have done that. What you'll notice is because we chose to have the buffer in here and stream chunks are just new buffers that can be pulled in, that actually leads to a much more closed way of running the system, which is nice, in that you can return a stream by value and it is correct. If we had to have the stream chunks always, then these pointers would have to be valid, which would mean that we would have to actually allocate memory in here to point to something that stores this contents. So having the first buffer that you're reading from always be inside the actual handle itself actually allows you a lot more flexibility with how these things move around and where they live, because you don't have to allocate memory. You can have them on the stack. You can have them welded into other structures that have been allocated, and you don't need to allocate another piece hanging off of it for the chunks in the case where you don't want a chained situation. So that's pretty nice, and it's just worth noting. So let's go ahead and finish up what we were doing there. Here we go. We call this content stream. Okay. And so when we call parse PNG, now we got to go back and look. I don't even remember what this thing took. So let's take a look. Maybe since this thing's only supposed to have one thing getting called, maybe I'll just loft that up into the H file so it's easier to read. That's really all it's for. I'm gonna put that up here, right? The info is optional, so maybe I'll just make that optional and then we're done effectively. I don't know why this doesn't take a pointer. So there's not really a lot of reason for it not to do that. Yeah, I'm not sure. Excuse me, I need tissue. I'm not sure. I'm not sure why parse PNG doesn't take... Yeah, well, you know what? I don't really care. I guess it's fine. So parse PNG will go ahead and read that content stream, and now we've got an image back. Again, all of this stuff, we don't have to worry about hemorrhaging memory or anything here because all of this stuff is in a temporary arena that gets cleaned up. And again, this is a really nice way to program. Again, a lot of people always ask about garbage collection and stuff like this. Memory arenas are a really good way to have basically all the things you wanted from garbage collection without all the unpredictability and weirdness. A memory arena, you can just pass it down, say, do all your work in here, you can allocate whatever you want, and then when you're done, it all gets cleaned up, right? You don't care about any stuff, and you don't need any complicated garbage collection analysis to figure out what is and isn't used, because you know that nothing is. So it's just a really nice way of like calving off sections of memory and saying, look, we don't really care about tracking stuff here. We're just going to remember everything that was allocated and just wipe it all away at the end. You know what I'm saying? So they're just really handy, and they're one of the big ways that you can get effectively the mental freedom from not having to think about your memory. There's a lot of techniques like this that you just, once you get used to using them, garbage collection just kind of becomes a non-issue, because you're like, well, 99% of the time, everything can just happen in a temporary arena or some permanent arena, and that's it. And you don't, like, there's a style of coding where everyone has gazillions of crazy pointers pointing to everything and they have no idea what's going on. And do you need garbage collection to maybe try and make some sense of it? Probably, yeah. If you're not coding in that ridiculous style, you know, it quickly becomes sort of a non-issue, just with a few simple tools, and memory arena being one of them. There's others. So anyway, but that aside, once we have this image back, what I want to do here is I want to break this image up into tiles, because again, for those of you who maybe haven't been following along the past couple days of coding, we definitely have a different sort of idea of how we're importing art assets now because of the new art we got. So we just want to loop through these tiles. These tiles, what you can see is we tried to make sure that they were nice and evenly spaced, so that we don't have to load a lot of metadata or anything to figure out where stuff is, just to keep everything simple. So if we come in here and take a look, I'm going to go ahead and select one of these as best I can here. Let me try and get that fairly exact. Okay, so you can see there's a pink rectangle there. I'm going to just do 1 pixel short of the next one, because this is like the whole area here. So what you can see about this rectangle that I've got selected, if I click on it here, you can see that this is, if you go out to the actual rectangle itself, like so, oh, that's nice. Anna did that really good. It's actually a 1 pixel border around the whole thing. So you can see there, it's a 1024 by 1024 rectangle with a pink border around the edge of it, right? So what we should be able to do is just step through the image looking at these chunks, and the images themselves, when we look at them, should conform. You can see 8192, 8192, right? They should conform to an even number of these chunks. So once we get an image here, we should be able to do sort of a like X count, Y count situation that we can determine directly from the image width and height, right? So what we do need to be a little more careful. So I just want to mention, I'm not going to do it now, but we are going to have some things like this that aren't that way. So the title screen and the cutscene stuff can go down a separate path that's just for large arbitrary bitmaps. Those will not be our bread and butter, but they will have to be handled. This is kind of fun. I like this. I like Krampus a lot. Krampus is great. My mom one time tried to say Krampus. She wanted to say that she likes Krampus. She thinks it's cool that Krampus is in the game or something. But she didn't remember what Krampus was, so she said Crumpus. And I feel like we need to put Crumpus in the game as well. I don't know what Crumpus is, but maybe I don't know, maybe Crumpus is like Krampus's weird younger brother or something. I don't know. It's pretty hard to say. Yeah, I don't know. If someone wants to file a bug report on the Handmade Hero GitHub with mark it as a feature request that we have Crumpus in the game, because we already have one up there which is to put a winners don't use drugs screen like the old 90s arcade games had. So something like that, another feature request, it might be a good idea to have a Crumpus in there. All right, so I'm going to go ahead and say that we've got a tile dimension here that's 1024. That way we can change it if we, oops, time dimension. Sounds like something that like Neil deGrasse Tyson would talk about on a talk show or something. All right, so we've got the X count and the Y count, and now we want to go through them. And again, like I said, we're going to have to do something other than this for the other kinds of bitmaps. So this is actually just one type of thing that we're talking about here. So we'll probably pull this out into a separate system eventually. What I'm going to do here, we could do is have a thing here where we say, process tiled import or something. That sort of thing. So we could do that, and we probably do want to do that, actually. So I'm going to go ahead and do that. And that way, in the future, because right here what I'm going to do is after we parse PNG, I'm going to want to have a thing that's like, if this is going to be tiled, then process the tiled import. Otherwise, process, something like that, right? So it's going to look something like that eventually, but it's not going to look like that just yet. So anyway, in here, we're going to take one of these image structs, and we're going to process this tiled import. We're going to need probably here the game assets, the asset source file, and there's the image there. We've got pretty much what we need at this point. To know the pixel region of the image that we're talking about here. So what we want to do is see if it's empty or not, right? We want to basically, analyze this thing to figure out whether this is something we actually want to check or not. Now, what I'm going to do is I want to produce a copy of this image of the tile into a temporary buffer that I can then use for, whatever I want to use it for, right? So in order to know whether this tile, in order to figure out what I want to do with this tile, I want to make that copy probably at the same time I'm checking. Now, there's an issue with that. There's an issue with that, and that is that if we go look at how the asset system is storing things, so here's the asset, right? And when we look at, there it is. When we look at the asset, we've got this asset memory header that's pointing to potentially, that you see that loaded bitmap structure, right? So the loaded bitmap structure, let me just grab that here. So the loaded bitmap structure has like a pointer to the memory, and it's got, the information about the bitmap there that we loaded in. So what we more or less want to do, I think, is load, we want to load into one of these. And we either want to load into one of these that already exists, that we've got loaded, or we want to make a new one that then will be used as the loaded one, right? So I think what we want to do is first search to see whether we have a loaded bitmap that should be used. And if we don't have one, then we will make a new one. And that new one will be provisional. So this is a little hard to explain up front, so I'm kind of just going to type it in and explain it after the fact so you can sort of see what I mean. But basically, the long and short of it here is I need to take this asset source file, right? And I need to look to see if I've got, where is that? Right here. I need to look and see if I've got an asset that backs this source file yet, right? So when I'm looping through my X and my Y count here, I'm going to look up this X and Y and go from there. Now, it's also worth remembering here that these have to be clamped. So we should probably also put in here something like this. Something that could be shown to a programmer so they know what's going on. If an artist accidentally makes an image that has more grid squares to it, we could say the tile count exceeds whatever that maximum tile count is, right? So something like this. Right, so this way, if you feed in a file and the file has too many columns, it will error out. Do the same thing here. And we know what these are. Oops. Right, X count max and Y count max are just the asset indices counts. So, you know, this will tell the artist, assuming that we print these on screen, which is my eventual plan, if they tried to make a file and it had, you know, 12 rows in it or something, we know that we only support 8 at the moment, and that's arbitrary. We could change it to whatever we want, but at the moment we don't have any plans to support tile sheets that have more than that in them. So when we do this, we want to just warn people when they put in an image that's not going to work. Now, when we detect that it's not going to work, I'm also going to go ahead and set the maximum so that we don't like end up crashing, because, you know, we'd rather just print out an error and let the artist fix it than crash the whole game, right? And then they don't know what happened because they can't even see an error printout because the game crashed, right? So we want to do a little bit of defensive programming there and just say, look, this file could have anything in it. We don't know, so let's go ahead and check it for error conditions that might happen in practice, that are likely to happen in practice, so that we can print out a usable error message for the person who made the mistake so that they can fix the mistake rather than just getting frustrated with it. So we have the looping over the tiles now. So what we want to do is look at the asset index in question here. So this is going to be looking at these asset indices. And I might just go ahead and say that I'm going to look at I'm going to actually snap an address to it so I can edit it if I want to. Because in the case where it's 0, I'm going to have to assign a new asset index in that case. So anyway, if we see that there is an asset index in question, then what I want to do is I want to gather the loaded bitmap that corresponds to that asset index, right? And so the way that I can do that is by looking up the asset itself and grabbing its memory header and then looking at that bitmap there. Right, and that's a pretty straightforward operation for us to do. We can load the bitmap in and be happy. So to do that, I've got to say, all right, here's assets. You can remember we've got sort of an array right here of them. So grabbing that one out. So grabbing out that particular asset, we can then look to see, we can then look to see if it has a header or not. I guess we can also look at its state. We could say if the state equals asset state loaded, then we can sort of use the bitmap that's actually in there, right? So looking at this loaded bitmap here, oops, that's not what I wanted. This is the loaded bitmap. So what I'm going to do, actually, I guess I can put this out here. What I'm going to do is say if we already had it loaded, then I'm just going to do it. I'm just going to load it into the place where it was already loaded, right? And one of the things that's true is we're going to have to deal with invalidating the texture cache as well. Texture cache is the wrong word. Invalidating texture memory. Because if this thing was loaded, it's probably already been sent down to the GPU. And if it's already been sent down to the GPU, we need to send it down again because we will be replacing this piece of information, right? We'll be changing the one that we actually used in that case. Now, one of the things that's a little tricky here is that we're kind of coming into this knowing that we're going to make another change, which is to change to using texture arrays now that we have everything at a similar size. So it's a little bit janky because we kind of want to make two changes at the same time. But I don't want to make those two changes at the same time, so because I want to do it in stages, especially because it's on Handmade Hero. When I'm normally programming and I don't have to explain things as I go, I will often make a number of changes at once because I know how they're all going to go and I'm concentrating fully and I'm not talking the whole time. So I tend on Handmade Hero to go slower for two reasons. One, because I want to show how things are done in stages, but also because it's much harder to keep everything in your head when you're talking the whole time and you have to do it in 2-hour increments over weekends, weeks apart and all this stuff, instead of just doing the whole thing in one day. So normally I probably would make the two changes. I'm not going to do it that way. What that means is we're first going to make the change of loading the things in, and then what we're going to do is probably wipe out this section entirely and go to a fixed buffer set where we just have exactly what we say here. Like we've got, probably more like this. Like we've got some 64 by 64s that we use for particles. We got 1024 by 1024s we use for sprites, and we got 2048s by 1024 by 1024s that we use for cutscenes, or something, right? So like that's roughly what I want to do. That reminds me. What reminds me? What is the size of this thing? Yeah, so what we'll probably do, right, is like we'll resize stuff like this down to a different resolution, right? So like, we'll open up title screen or whatever. So this is the original title screen graphic. And what we'll do is we'll say, all of this stuff has to fit into something that's going to be, oops, that's not what I want to do. Right, so we'll use that resolution of the thing. And we'll just say that like all of our cutscene stuff fits in to images that work like that. So again, it's a bit of a Procrustean bed situation, but it simplifies our life and doesn't really cost us that much at the end of the day. It's pretty easy to fit art assets into those things. So what we'll do is we'll fit all of the cutscene art into packs like that, and then we'll take those, and those can be, you know, the highest size texture array. The 1024 by 1024s will be the sprites, and then there'll be one smaller one for things that are like, you know, particle effects and stuff like that that don't need a big one. 1024 by 1024 might be too large. So what we might do is downsample everything by 2 and go with 512 by 512. It's hard to say. If you take a look at the actual sizes, oops, I'm not supposed to use that. Everyone chastises me for it. If you look at 1024 by 1024, assuming we store them uncompressed completely, so we don't use DXT or anything, then the size is 4 megabytes per sprite, right? So if you figure that on a higher end card of like, say, 4 gigabytes, that means that a 4 gigabyte can have 1024 sprites resident at a time, right? There's no way we're going to have 1024 sprites on the screen in different ones. That's just not likely, right? So we should be fine to use super high-res artwork if we want to. Even without compressing it, we're probably fine. And so I would imagine we won't have to downsample the artwork. We can just use it at its native resolution, and that'll also give us some nice bonuses. Like if we want to run it 4K, our art can stand up to that because it is 1024 by 1024, so even big things will still look nice and crisp. So I'd say okay. Now, what I said isn't quite right because we'll probably need to store some bitmaps. So it's really, it's probably more like 500 different sprite bitmaps at a time. So, you know, maybe that gets up to the point where it's a little bit too much pressure. I don't know. Either way, we do need to kind of be aware of that boundary because on lower end systems, for example, we would probably want to have the option of loading 512 by 512 sprites or even 256 by 256 sprites, because if you have a graphics card that only has 1 gig of memory or has 512 megs of memory, or if you're running on some kind of a low-end platform we want to try supporting someday, like a Raspberry Pi or something, we don't want to have these huge sprites in there. So we do need to sort of keep that in the back of our minds, that there's sort of, there's 1024 by 1024 is the largest. On the most powerful machines, that's the size we will load our sprites in at, but that's not the size that they will always necessarily be if we want to support lower end configurations of machines. And if we look at the quality difference between the two, you know, it's not going to be huge. If we open up something here, like here's Krampus. So if we take one of these and we look at it, you know, you can kind of see what it looks like here, right? If I was to scale this down to what it would be if all the artwork were 512 by 512, you can see what it would look like. It's definitely blurrier, right? But it's not. It still retains the general. I mean, you're not gonna. It doesn't look awful or anything. On the other hand, if we do go down to 256 by 256, at that point it might start to get a little ugly, right? So that would be that, right? And so what you can see there is as you get down to that size, you sort of start to lose a little bit of the quality of the line work there. So it is uglier at 256 by 256. Some of that could be mitigated by better downsampling, you know, better scaling than Cubic. Something that was more aware of the fact that it's kind of a line art cartoony style, for example. So there's that. But also the other thing you could do is, if you really cared about something like this, you could have your artist work at this resolution originally or touch up these themselves to fix the line art. We're not going to do that because we don't care about that at all. So we will probably just say 512 by 512 is the size the sprites are when we down sample. And that gives us 4 times the number in memory at any given time. So if we assume a 4 gigabyte graphics card as our spec, if this game releases, I don't know, in 2020, let's say, a 4 gigabyte graphics card is probably going to be pretty standard at that point. But even if it's not, a 1 gigabyte graphics card should be pretty safe. Now, it's hard to say. I don't really know what the Steam hardware survey says these days. There we go. But, just looking at it here, right, you can kind of see that a 1 gigabyte graphics card, even today, is kind of a minimum on Steam. Like, the total number of people who have a card less than that, who are checking into the Steam hardware survey, is so low, it's like 5% total, right? So it seems safe to say that in another year or two, which we wouldn't be shipping to any consumer before then, it seems pretty safe to say that we really wouldn't have to care much about anything below a 1 gigabyte graphics card, and that should work just fine for 512 by 512 sprites. If we have a particularly good cache predictor, that may actually even work fine for 1024 by 1024 sprites, depending on how we choose to do them. And again, that's uncompressed, right? That's if we don't try to apply DXTC texture compression to them or something like that, where we would, be able to do it. But I don't think we're going to have to do that because, again, if we just try really hard to do good predictive streaming, we should be able to not even have to compress these sprites. If we do have to compress these sprites, I would say palletized might be the right way to go, although that does put extra stress on the shader, so sometimes, so I don't know. But anyway, because palletized would probably just work, whereas DXTC would introduce some artifacts into these sprites probably. All right, so anyway, just keeping all that stuff in mind, primary display resolution is pretty interesting here. No one's at 4K. You notice? The 4K revolution has not happened yet. So everyone's got a gigabyte of graphics, but no one's got a big desktop resolution, a big primary display resolution, right? It's pretty interesting. Looking down these stats is it's pretty interesting. 8 gigabytes of memory, man. There's so much memory in the systems now. Like, it's just nuts. Just nuts. I love like some huge over a third of the people have more than 12 gigabytes of memory in their machine. There's so much memory now. It's nuts. Just nuts. This stuff's looking pretty good too. Sorry to the people who still have the old AMD Phenoms, but I'm guessing I'm guessing SSE4 is going to be here to stay pretty soon. So you're just going to have to not use those chips anymore, because I mean you're down to 7% of the people don't have SSE 4.2. It becomes pretty hard to justify not moving to that platform at this point. I wish AMD had not been so slow on the uptake of those. Anyway, those are almost certainly Phenoms in there, I would assume. So anyway, yeah, there we go. Whatever, such and so forth. Yeah. So, all right, let's keep going here. So what I was saying originally is as we go through these tiles, we take a look here and we look to see whether we've got an asset index or not. If we do have an asset index, we'll try to see whether or not the thing's loaded, and if it is, we'll use the bitmap that we've already got. If we don't have a bitmap, at that point, what I want to do is use the provisional bitmap. So what I want to do here is say bitmap equals, provisional bitmap. Now, what's a provisional bitmap? A provisional bitmap is the bitmap that we use to load things before we know whether we're actually going to keep them or not, right? So it's basically just a chunk of memory that we're not sure whether we actually need yet, but that's what we want. And so I'm going to do a thing here that's like provisional bitmap equals, I don't know, something like this. Get provisional bitmap, and I know that I need a tiledim by tiledim bitmap for my use, right? And so I'm going to get one of those. And we're going to, this is just stub code. We're going to see what this is going to be about in a second. Anyway, once I have one of those, what I want to do is I want to move through all of the pixels in the source. And I want to I want to do two things. Copy it to the provisional bitmap, the place where I might actually want to use it. So I want to do that, and at the same time, I want to see whether or not I think that there's anything actually in this bitmap. Okay. So what we know is there's a 1 pixel border around everything. So we want to actually do this rather than the full size of the thing. The reason for that is actually a little bit difficult to understand. We covered it a long time ago on Handmade Hero, but it's actually critical to have a 1 pixel wide blank border around all of our sprites. Why? Because we don't want to rely on any kind of texture border hardware or other kinds of features like that. We want to be able to sample from the edge of the texture and not have anything be there. Now, I know this sounds a little confusing. Let me just restate why this is the case. It's actually relatively important to do this to be able to support software rasterizers as well, which we do want to do because we would like, again, to update our old software rasterizer to work with our new system eventually. So it's not a non-issue. It's something we actually want to be aware of for software rasterizers as well. So so what we want to say about texture borders is just that, look, let's suppose I've got an image. And, here's the image that we're talking about. It's a 4x4, right? And it goes all the way to the border. Okay, so it's just a little squiggle. Well, we want subpixel accurate rendering and anti-aliasing on all of our rendering work. That's just something we set out to do at the beginning. It's much more high quality. It looks much better than crispy, nasty pixel garbage. So what we want to be able to do is stuff like say, okay, this sprite lands at a boundary that's not right on any of these pixels. So maybe, it looks like this. Okay? So what that means is this needs to be spread out among those 4 pixels. So each of these pixels gets a little bit of a contribution from this pixel, right? Make sense? And how do we do that? Well, the way that we do that, because remember, we only want to fill each pixel once. So when we go to draw this pixel, what do? Well, we sample where the center of that pixel would be, right? And we bilinear filter between the colors that we know are in the texture to produce the correct color for that pixel, right? Right. That's how we get subpixel movement of a sprite through a pixel grid. This is all old news. We've done this in Handmade here before. I'm just trying to refresh your memory. But what do we do for this pixel? Well, for this pixel, we need to sample this location. And the problem with this location is that it doesn't have any information about what exists out here, because it is fundamentally outside the texture. Now, what we want to do is support clamping. We want to be able to support the texture mode that just says, if you were to sample outside the texture, just sample the thing that's inside the texture closest to you. Because that's the most efficient thing for us to implement in a software render. It's also something that's available on all hardware without any additional operations. You can just say clamp and you get clamping. Well, we can't do that here. We would have to use what's called a texture border, which is additional texture border color. It's actually what it's called. Sometimes you can use, there's a thing called texture border, which is separate. Texture border color is what we need, where we set the texture border color to 0, 0. It says if you sample outside the texture, use this color instead. That's an additional operation we don't want to do, right? So by creating all of our sprites such that there's a 1 pixel border around them, that's no good. So we just say, look, if it's a 4x4, that means sprites are 2x2 effectively, right? Now, obviously, we're not going to do that. It's 1024 by 1024, so really they're all 1022 by 1022, right? All of these have to be left blank. And the reason that they have to be left blank is because they need to be able to sample in between these two to get a clean result. That's just how it goes. Are there problems with this approach? Yes. What is the problem with this approach? MIP mapping. And this is where we start to get into a whole big can of worms that I don't really want to cover today because it's not super relevant. But suffice to say, if you really want to do this stuff accurately, you almost need to do your own texture sampling in the pixel shader, because one of the really big mistakes that was made when people originally designed graphics hardware was they designed mipmap sampling wrong. I hope that's not a controversial statement. I don't think I'm stating it controversially. But basically what happened is when they created MIP mapping, instead of correctly identifying the fact that textures should be sampled from the half pixel boundary as 0, 0, they made 0, 0 be the outer corners of the texture. The result of this is that MIP mapping never properly works for images. It's always wrong. And the degree to which it's wrong has to do with how many MIP maps down you've gone. This manifests itself in a lot of really serious problems for when you want to put tiles next to each other that are supposed to be continuous, stuff like this. There's a lot of really bad errors that therefore occur. And yeah, I don't know any other way to say it other than MIP mapping hardware was built incorrectly. It's always been wrong. It's wrong still today. So if you actually want to support the correct movement exactly right with MIP maps, you actually have to do your own texture filtering and your own texture sampling inside the shader. And there's no two ways around that. What we will do on Handmade Hero for that, I'm not sure. I don't know that we really want to try to do that. I think Handmade Hero, it's perfectly reasonable trade-off to say we're just not going to go down that road. But it's worth noting that you need to do that. Now, we can take another step in Handmade Hero that would actually create a circumstance where we don't have to worry about that as much. And that is border thickening. What you do there is you say, all right, since we know that we're probably going to only care about 128 by 128, 256 by 256 512 by 512 and 1024 by 1024, but we're never going to shrink these things down really to 64 by 64. What you can do is leave a border that is that thick around the whole image, right? So for example, if you go into GIMP and you look at what, and you look at what that would imply here. Actually, that's not what I want. So if we were to take Anna's reference sheet here and take a look at what this would actually imply. So I'm going to go ahead and just make a little selection here. So if I pull this out to encompass the entirety of one sprite cell, so if you take a look at one entire sprite cell, this is a 1024 by 1024, you can see a rectangle said down there. So if you were to look at one of these and I was to red out the entire area of it, right? And then what I did is I pulled this down so that we actually had an 8 pixel wide border. Sorry. One. Oops. Okay. And then we just said, all right, there's the actual space of the image. So one thing we could do is just say, let's leave that much, right? What will then happen is there's an 8 pixel blank border at 1024 by 1024. There's a 4 pixel blank border at 512 by 512. There's a 2 pixel wide border at 256 by 256 and a 1 pixel wide border at 128 by 128. So only when you map down to 64 by 64, which is getting pretty darn tiny, will you actually end up with a sampling problem, if that makes sense. So we could ask Anna to do that. If we take a look at the way these actually look here, not sure how hard that would be to do. So, you know, a lot of them just already are, you know. So what we could do is just like print a warning, you know, about it if it's inside the border zone. So hopefully that makes some sense to you. And basically what I'm saying here is like, look, if we don't want to tackle the whole mip-map problem, then what we could say is just 8 pixel wide borders on the input, and we go from there. So yeah, that's all there is to say about that. So I'm just going to go ahead and say let's warn on that. So if we see anything in that apron, we're going to go ahead and warn. And now I think about it, yeah, like let's just go ahead and do something like that. So what we could do is say, look, we're going to copy the whole thing, but if we see anything in that apron, we're going to we're going to warn about it and go from there. Now, you know, one thing that I guess I'm not sure about is, you know, we could also store these things a little more minimally. When we actually put one of these, bitmaps in there, I could actually just sort of scan for sizes. We got a lot of stuff we can decide to do here. I'm not sure which ones we want to do. But anyway, we want to take a look and see, you know, if the source has an alpha value. That's what we want to know. So we want to take a look at something and say, like, okay, you know, there's a source that we read in from somewhere, like source pixel. We want to take a look and see if the source pixel's alpha channel has something in it. So basically, like this, I guess the other thing we could do is shift it down, but we just want to see if the source pixel has something in it that we actually want to read. And if it does, we want to set all of the, all of the different borders of the image should shrink to here, so we can sort of figure out like what the region is. I'm going to create a thing here for that. Do we have a... What kind of rectangles do we have? So we have floating point rectangles. I feel like that's probably fine. Hard to say. Well, all right, let's do it this way. So what I can do here is say, look, we've got some bounds. Every time we see a source pixel, in here, we're going to say that the min x equals the minimum of the min x and x. The max x equals the maximum. Or I think we want... No, we want that. Yeah. So we basically expand, our notion of what's enclosed based on what we see. So if we read all the source pixels in, this will tell us the bounds of the actual image. And then what we can do is when we're done with that particular tile, we can now see whether there was anything in it. So basically, like if min x is not equal to u32 max, right? Or more specifically, what we could say if min x is greater than or equal to max x. Oops. Less than or equal to, right? As long as there was something in the image, then we'll do something with it, right? So if there was something in it, then what we want to do is we want to issue errors if you're in that pixel border. So if the min x is less than or equal to border dimension, let's say, I guess I want less than, or the max x is greater than or equal to the tile dim minus the border dimension. So in other words, like if the tile dim is 1024 and I want an 8 pixel wide border around it, then I want to know if my max y gets hit directly on that value, right? Of 1024 minus 8 or 1016, right? I want to know if I'm on there or over it, and similarly, I want to know if I've gone below 8, because 8 itself would be fine, but 7 through 0 are not fine on the other ones, right? So when we pass in here the tile dim, we also know what the border dim is, and maybe the border dim is 8. And here we can sort of say, if we see one of these, we can print it out. Now, as onerous as this is going to be, I guess really what I should do is specify specifically which ones are in and out. laboriously, like each individual one, with a different error message, just so that the artist can tell if they get used to these error messages, they can actually know what exactly to do. So what I could say here is like tile. Something like this. You know what I'm saying? And I guess what I could do to make this a little bit more straightforward is maybe something like this. Oh, well, but that's not going to work because I want to print out each individual one. So yeah, I think I'm just going to leave it this way. I don't think there's going to be... I mean, I could... There's some other ways I could write it, but I think that's going to be actually the easiest one. Yeah. And these are top down because PNGs are top down, right? So we're looking at it from the top down. And I think the artist wants to think of it from the top down too. So this is probably the right way to report it, right? If we're gonna flip the image, we're gonna flip it later into like an OpenGL texture style or something like that. But I think that's what we want to do. And we can probably say here that this is also like, oops. So we can pass the border dimension in. So in case we change that, it won't say 8 pixels and actually mean 16 or 4 or something. All right. So when we read this thing in, now we've got a way to warn if it goes into the border area, which isn't technically a problem. Like the game will still run just fine. It just there might be some anti-aliasing artifacts, so it doesn't. It like has a little weird fringe, like an artifact that you'll see when it mip maps down. So a 1 pixel border is really all that's necessary for the highest level of resolution. But as you mip map further down, you'll get more and more problems. So if we take a look here, we loop through the X, Y index stuff. We go through looking for bitmaps. When we find one, now we're going to copy into that, or we'll see what we'll do in a little bit. But when we grab one of these, then once we figure out the borders of the thing that's actually in question, we know whether we need to retire it or not. And that's when we would go ahead and write it back into an asset pack file. Or who knows what, right? So let's go ahead and start implementing that code path. What I want to do here is create a dest pixel pointer and a source row pointer. The reason I have to do these two separately is dest pixels, we know that we're going to produce optimally packed stuff for our file that we're saving. And this is where I was sort of saying we kind of get into a situation where I don't know how we want to deal with this. For fast development purposes, I think what we want to do is we just want to store everything as 1024 by 1024s back to the pack files that can just be overwritten. But then eventually I think what we're going to want is we're going to want a thing that goes through and compresses and just takes the min-max of the thing and shrinks it down. Because we don't really need to store all the empty space it's just not necessary. So we can probably do something like that eventually. I just don't know that we want to do it quite yet, because if we do it, then we have trouble replacing assets and we have to keep a free store and all that stuff. Now, maybe we want to do that. It's hard to say. Probably eventually we would if we actually wanted to lean on this system and let it be something that people use after the game's already shipped to put their own art in or something. But hard to say. Anyway, so what we want to do here is take a look at the loaded bitmap stuff. Here's that memory pointer. I don't know if we've got a way to quickly get doesn't look like we do. So I guess I'm just going to go ahead like this. So we've got some bitmap memory we're writing into. Our source is going to come from this image here. And so this is going to be our source row pointer. And the source row pointer is going to advance every time by the width of the image, right? So then I've got a source pixel. That's just going to be the source row pointer. And I want to advance it as far forward as I need to for the X position that I'm at, right? Same with the Y. So I've got a Y index, and I know that I want to do tile dim times image width, right? So I want to start there. And then as I go forward, and in fact, you know what, I can just pre-step this one as well. So what I can do is just say also, you know, step the Y at the X index times the tile dim forward. That just brings me down to the start of the tile. That's the first tile. And then every time I go on a row here, I'm already at the right place in X, so I just need to advance the source pixel pointer each time. So that does the complete scan. If I want to write into the dest pixels, these are just direct. So once you have the source color extracted, you're just writing it directly into the other bitmap, and off you go. I don't think there's anything else we need to do here other than extract it, right? So I think that just does the extraction. The only problem is when we actually need to get like a provisional bitmap, we don't have that yet. So once we get in here and we see that we've actually got something we're going to keep, then we need to actually do the work of pushing that back through into the system. So what I want to do here is say, all right, let's go ahead and load up the file formats here. So what I want to do is I want to write this back to some location. And there's two cases that I might have to handle. One case is where I don't have an actual asset yet, right? So that would be the case where I've got like an HHA, like there is no HHA on the disk that actually holds a backing store for this asset. It's new. So it's not the case that I'm going to go back in and overwrite an existing asset. What I'm going to do instead is create a new slot for a new asset. So the HHA header for one of these files now essentially has to get expanded with an asset count that's larger than it used to be, and these arrays have to expand, right? So just thinking through how I probably want that to go, I think I just want to kind of pile up the data in a separate growable file and probably just have there be something flexible that writes these out, which can then be compiled down to the existing HHA at such a time as I want to do that, right? Yeah. So I think what I want to do here, once I get one of these, is I want to look to see whether I want to store over an existing asset or whether I want to write an asset anew. So I think what I want to do is actually, and considering this a little bit more carefully here, yeah, I'm pretty sure what I want to do is write out the asset here. Yeah, to a known store. So I think this is what I want to do. I think I want to have one file for each size type. Well, I mean, I don't even really have to do it that way. But I want to have basically a file that I use that's just a backing store for these things that I just write into, and when I, quote unquote, free one or overwrite one, then what I'm going to do is I'm just going to overwrite that part of the file with the new data, just like I would in memory. And then when we want to compress these down into an HHA, what I can do is run something that actually does that compaction and goes from there. And this could be a pretty nice way to just do the development in the first place. Basically, we just say, look, all of these PNG files, they just get compacted into something that we can read from reliably. And that happens at runtime automatically. The artist doesn't have to think about it. And then when you want to actually ship a build of the game, you can just run something that trims out the dead space, right? And we could even put a little simple LZ compressor in there, kind of like what PNG had, to reduce the size of our game's asset footprint. Because at that point, it would probably be pretty cheap to do that. So we could probably do something pretty nice there, is also my guess. Yeah. Yeah, so I'm in favor of that. I think that's good. So what I want to do here is first I need to figure out what the tags for this thing are going to be, because I don't know what the tags for this thing are going to be. So we kind of have to imagine that the tags for this came in some way that we can use, right? The X and Y location, the X index and the Y index, have to be translated into tags somehow. So we need a to-do here that's like translate the tile index into tags based on the name of this file, probably using something passed into this routine. So like that's the part about the tags I said we had to do. Once we have the tags, then we have to do like a write asset data. The write asset data call is going to, excuse me. The write asset data call is going to take some information with it here. Let's say that that's going to be probably 2 parts of data. So we're going to need a couple pieces of information here, but we're going to need the bitmap, so the loaded bitmap, and we're going to probably also want something like this. Like metadata and data, right? So when we write the asset bitmap data out to the file, what we're going to do is just give it that bitmap. The bitmap should have everything that it needs in it, which is got everything here. Although I guess that also has the align percentage. So I guess we really are just going to have that because it's got the metadata in it as well. So I guess we have that right out this, and we need to write asset tags similarly, right? Because we need some way of associating that. Now we know the asset index, right? The asset index here, we need to assign an asset index. So here we need to say, look, if not asset index, this needs to be assigned an asset index. The asset index in this case is just going to be however many assets the game currently has when it's running. So inside the asset system here, let's take a look. Where is my asset count? Yeah. So once we assign a new one of those asset indices, then we know that the asset itself that we're looking for is just that one, right? I think it's just asset, actually. And what we do want to do here probably is, well, I think we're going to make this so it can't actually fail. So we're probably going to need to do a max asset count thing here, which will grow that array as necessary. But taking a look at what we're doing here, so we come through, we got the asset index and all that nice stuff. And once we have that, we should be able to say, okay, we're going to write asset tags for this asset index. And yeah, and I guess maybe, you know, now that I think about it, that's probably something we can just do like this. So we can go ahead and say we want to write asset tags for that asset index, which we assigned a new one to. We can probably also have, you know, I don't know if we want to just have this allocate more space in the array as necessary here, or if we don't. That's kind of 6 and 1/2 dozen of the other. But anyway, we need some way to write out the asset tags here, which we don't know. And then we need a way to write out the asset bitmap here, which that's a lot simpler because we do know everything we need to know about that. So what I'm going to introduce there is probably just another way to use an HHA file that has this information in it. So we'll kind of look at how that's going to work in a second. But we'll look at that. Yeah, we'll look at that a little later. So let's see. How much time do I have left? I've got about 20 minutes. So, you know, I think I maybe don't really want to do this way. I think I'm going to go ahead and say I'm going to get rid of this. So I think what I want to do is we're actually always going to go into a provisional bitmap that we just do a write. I think we're going to go a little bit of a slower route here and just live with that. Yeah, I think I like this better. And then what we'll do is we'll flush the asset cache and force it to re-initialize things. I think that's just better. So what I'm going to do here is say, look, we're gonna have a provisional bitmap here that we use, and that provisional bitmap is going to come out of the asset temporary memory because we're not going to keep it, right? So, and in fact, what we could do, yeah, I think I'm just going to do it this way. So we're going to pass in the temp arena, and what I'm going to do is just say, look, let's get like a pixel buffer here, and that pixel buffer is just going to be an push array on the temp arena of the tile dim times the tile dim of U32s. So we're just going to create that pixel buffer, and we're going to use that for all of our operations. So this will extract the information here as well as do sort of analysis to see whether it fits in there properly. When we're done, we'll go ahead and write that asset bitmap out, based on the tile dimensions of the thing. And, that's the size that we want to send out. And so the only thing we really then need to know is where inside our sort of, where in our, table of asset, sort of temporary asset storage, do we want this thing to go, right? So for that, I just really need a notion of, like where in the asset temporary storage these things went, right? And if we look, the HHA itself has that information. So really what I want to do here is, it's actually pretty straightforward, I think. When we get an asset index out, if we have an existing asset index, the first thing I want to do is, and you know what, maybe we don't really need to go through this rigmarole. I'll just, I'll just reassign it at the end, right? So that way we don't have to keep putting the star in there. So I'm going to grab an asset index out of here. I'm going to look at the asset index, and if it actually is valid, then what I'm going to do is I'm going to look to see what that asset actually has, like so. So do it like that. When I look at that asset, I should be able to see inside the asset file index, I should be able to see whether or not this file is one of our compacted or non-compacted files, right? So I can go grab the asset file, oops. And when I grab that asset file, inside the asset file, I can remember in here which one it is that I actually wanted, like what kind it is, right? Or, maybe something like that. So basically, if this asset file let's try to type. If this is an expandable asset file, then I could do it. If it's not, right? If this asset file is not expandable, then I effectively don't have an asset index I can actually use, right? This asset is no longer valid, and it shouldn't actually be used for anything. So, excuse me. What I would want to do at that point is like nerf the old asset file so that we know that it's not actually one that we want to continue to use, right? So in the HHA itself, we want to kind of nerf this asset. So we want to like mark asset as old or something like that for this particular asset. So we want a mark asset as old here, and we then want to also say that we don't have an asset to rewrite anymore. So then when we come through here, if we don't have an asset index, what we want to do is we want to assign a new asset to the asset index that we have. So we could do this something like this, right? So we want to basically say, hey, let's get a new asset index that we can use to do stuff. And then once we have one, we will fill that out with the new data that we have, right? Now, the other thing that I probably want to do here is maybe change this around a little bit. So what I would want to do here is if this was expandable, then well, actually, I guess, no, that's not true. I take it back. There we go. So what I want to do here, I guess, is when we grab this asset out, there is a little bit more we can do with it. So I want to rescue the information that we were using in terms of like alignment and stuff and probably preserve it. Because whatever the artist set up last time is probably the best guess for setting it up this time. And if they don't like it, they can always change it. But at first, we probably want to use that thing, right? So we probably want to store this. When we have one. So that way we'll keep that around, even if we realize that the asset's old and we're not going to use the old location in the file to actually touch that asset. We're still going to use like the metadata from it that we had originally, like the alignment point, right? So then when we come in here and we say, oh, you know, we didn't get an asset or whatever, then we can say, let's reserve a new asset. And then we can start assigning stuff to that new asset, right? So we can grab it out of the system. We can say that its HHA equals our RHHA. And we can go from there. Now, that's probably something we can do right here. Like so. And then we can write it back. So now what we need to do is actually set this stuff up. And when we actually do this like reserve new asset, it's going to have file index and asset index in that file. That will be set for us when we do the reserve. And so we can probably just proceed to looking looking at the actual HHA data. So looking at the actual HHA data, what we can see here from the HHA assets, here we go, is the data offset and the first tag index and the one pass last tag index. So the first tag index and the one pass last tag index part of things, we need to set to whatever our, whatever the actual data is here that we need, that comes in from our prefab way of setting tag information, right? So that's the part that we don't know yet, but that we need to put in here at some point, right? So we're going to say HHA asset first tag index equals something, HHA asset one pass last tag index equals something, right? And we don't know what those two are, but then we need an HHA asset data offset. That's what we actually need to know to write this thing in. And then similarly, we know that this is a bitmap that we're doing here. And so the bitmap needs 2 dimension informations and 2 align percentage informations. The dim informations we'll just put in here. The align informations we're just not going to touch. We'll set them up here to the default, which I assume is like 50%, like probably the middle, right? just because like that's if you didn't have if no one had ever told you where the hotspot on a sprite was, the middle's probably a good bet. Now what we could do is actually take the middle of these, so the middle of the actual image that we get, but I'm not going to do that because we don't really know that that's any more accurate. We'd just be purely guessing that it would be. So here we are setting the tile dim. That's going to be correct. So really what we need here is reserve asset space. So this is where we would reserve the asset space. There's two cases here. One is if the asset file, you know, the expandable, unexpandable bit. I think this probably wants to look like this. And yeah, and it probably wants to check to make sure the tile dims were the same. So what we want to say here, if it's not an expandable file, or it's not matching dimensions, I guess I can just do it like this. Right, so if it's not expandable or either of the dimensions have somehow changed, which we really shouldn't have happen hardly ever, but you know, we want to make sure that we support it if for some reason it did, then we're just saying like, no, this is not, the old asset is no longer available. It's just old data that we can't really use. And now we need to put it into a new place, right? However, even as I'm saying that, I guess now that I think about it, there's no such thing as an unexpandable file. We can always write new data at the end, right? So really, I think what we want to say, I think we're just fine. I think all we need to do is say, is it a different size? Because right, I think it's fine. So we just want to say, look, if we can't just romp over the thing with the new thing, right? Then sure. Yeah, so I want to say this is really just this. Yeah, so you know what? I think this is really, it's really this, actually. It's really just, look, if we don't have an asset, we need to reserve a new asset, duh. Otherwise, we can just say, look, if the data offset is 0, or the dimensions don't match, then we just need to reserve space for, you know, we just need to reserve space for something that's that big, right? And so that will get us a data offset in that'll give us what we need to write into that file, and it will bring the data. It'll give us back the data asset. the data offset we can use to actually write in there. So we need to set up the tags, but then I think we're just good. Like, this is actually easier than I thought it was going to be, I think. So we just reserve asset space in that file. Like that. So I can get a new asset, and I can get, if I need one, and I can get more data space if I need it. And then once I have it, I just write it in there. Right? So I think really that was all I needed to do. And then when I get to the point where I've where I get to the point where I want to write out this asset bitmap, really it's not writing an asset bitmap anymore. It's more like saying, look, write this asset data we know it's this big. Oops. That's how big the data is. So we want to reserve that much space. It gives us back a place to put it. Then when we write the asset data, we say, hey, the asset data we want is this, right? It's this big. And I want you to put it here. Right? So like, there's the place to put the thing. At this offset, it's this big, here's the data, write it out. So then once we do that, the only other thing we have to do is to overwrite the asset record itself with the new asset record. And so we would just say, hey, write this asset back out to the file from whence it came. I think that's all there is to it. I think that just updates everything. So the only really thing we need to worry about is the tags, like I was saying before. I think that's literally it. Like, that does the whole shebang. And the only things we need to implement is something that reserves extra asset space and something that expands files as necessary. Two very, very simple operations that really just won't be very hard to implement. I'm going to go ahead and nerf this for now so that we still compile. Wait, what? I didn't define those? It's the easiest one to define. That was this, right? Yeah. And that's supposed to be x index, y index. Same with the one down here. Yeah. So we need to grab that out. There we go. That's all good there. I think that's that, actually. Yeah. So I think now we're pretty good, actually. Here's process tile import. I can pass this, all that stuff. I think that's all good. And so really what we would need here are these functions. Oops. So that's the asset index. We need the reserved data one. I don't remember what this is called. Asset file. And asset data size. I suppose this could probably be a U64, but we'll leave it like that for now. And then these two. So I think that's all we're looking at. And that's all compiling too. So these are like trivial to implement too. So these are really easy, which is great. So I think we are now basically down to exactly what I said we were going to run up into, which is the tags. So we're going to have to rethink tags next time. And that's going to be a little bit of a grind because we're going to have to really put on the thinking cap for that. But that's about it. Like, I think we're in pretty good shape otherwise. I think the rest of this stuff just sort of works. I'll go ahead and go to the Q&A, but I think we're in good shape. We rewrite the software rasterizer with SSE4. I don't know. Probably, honestly, probably what we'll do for the software rasterizer is we'll rewrite it with AVX512. And just because it's just you're not going to run a game nowadays on a software rasterizer. Like that's just not a thing you do. So we've always only ever done it because I think it's important as a learning exercise for people to see how it works, because otherwise you have no idea what your graphics card is doing. You don't really get it. You know what I mean? So we can try to, what we can try to do is once the game is done, we can rewrite the software rasterizer and we could use AVX512 because then we can actually do a pretty high performance one too, because that's got like lane-based gather and stuff. So for texture fetches, it actually works. You know, I don't think there's much point in rewriting the software rasterizer with SSE4 because SSE4 doesn't have any stuff that we really need for software rasterizer. Like, we wouldn't really gain anything all that useful. There's maybe a little something here or there that's useful, but it's just, yeah. So I think the software rasterizer would probably be like AVX512. So it's got lane-based gather, and that's just purely exercise in learning. And AVX 512 is the only actual instruction set that was sort of designed for rasterization anyway, you know? And don't feel bad about not having AVX 512. Nobody does. I don't have it either. I'm just saying when we actually go to do it, if we're lucky, AVX 512 will be around. If we're lucky. Maybe it won't be. I don't know. I mean, one of the problems is that AMD seems to not be going that direction, unfortunately. And the problem is, so the problem with AVX 512 is I don't care about the 512 part. I care about lane-based gather, right? So you still haven't bounded hash value and check for... Oh, you're right. That's a good point. We should do that. Right here. Right? So... in here, we've got the source file hash. We only support up to 256 wide hash there. So let's go ahead and bound it to that. Can probably do a mod there because the compiler is probably smart enough to change it. So you could, I would imagine the compiler is smart enough to change that into an and by 1 minus. I don't actually know. I don't know if it is or it isn't, but let's just say. I would be shocked if it couldn't do that. It's a very basic transform, but you know, might as well look. It's not a performance critical part of the code anyway, so we could just do the mod. How long until Microsoft tries to force Win32 to become obsolete, and what comes after Win32 for games? So, if I may make a rather dire prediction, I think Windows 10 is probably the nail in the coffin for games on Windows, is my guess. And I will elaborate on that as follows. Yesterday, I was trying to play PlayerUnknown's Battlegrounds with Anna, the artist at Molly Rocket, and Matt Cornell, a friend of mine from California. Here's what happened. Anna tried to plug in a mouse that she had used on her laptop. It's a Razer Orochi mouse into a PC that she wanted to play the game on. Okay? Upon plugging in the mouse, because I guess the Razer Orochi mouse has a very high sampling rate or something, and there are no default drivers for this mouse, I guess, on the PC, it was essentially unusable. Like moving the mouse only a little bit, like moved it all the way across the screen, even though the like sliders on the mouse configuration were not set to like high speed or anything. So it wasn't really usable. So over the phone, I tried to walk her through how to fix this. Well, unfortunately, Razer doesn't distribute drivers for their hardware anymore. In order to fix the mouse, you had to install Razer Synapse, the only way that they actually distribute drivers for Windows 10 anymore. She tried to install Razer Synapse, and of course it was Razer Synapse version 3, which is the default download. Razer Synapse version 3 doesn't support the Razer Orochi mouse, so it didn't do anything. It just forced her to create an account and didn't do anything. I then had to walk her through uninstalling, right? And mind you, when you're trying to uninstall something on Windows 10, what happens is you type uninstall into the start menu, it gives you some uninstall, whatever the last uninstaller was. And it just says uninstall, right? In the little thing. So she clicks that and it says, do you want to uninstall Mumble, which is like the last program that got installed or something that had a thing called uninstall. And she's like, no. So I'm like, you have to type add or remove programs and click on that. Find Razer Synapse in the list, uninstall it, go back to the Razer webpage, download the Razer Synapse 2, install that. That actually identified the mouse and was able to install the driver. Okay? That was getting Anna's mouse working. So then we tried to play, but unfortunately, Matt Cornell's Windows 10 had updated and apparently melted down. Now it just blue screened all the time, and he couldn't tell why. He never got it working. By the way, he's a tech professional. He administers websites for a living. He runs Linux servers all the time. He knows everything there is to know about administering a computer. He couldn't get Windows 10 to run after like 30 or 40 minutes, so we just gave up. And that was our experience playing games on Windows. This garbage is completely unacceptable. And there is no way that the player base on Windows will continue to grow with this kind of crap. We are talking about an operating system that pops up a dialog box in the middle of your game asking you to reboot. All right? It is totally unacceptable as a platform. They do not know what they're doing, and it is only because people love PC games so much, and people like Valve have stepped in to supply something like Steam, that it even exists at all. We are hanging on by a thread, and Microsoft is essentially completely ruining our only existing pseudo-open game platform that we still have that's actively being used. I don't think it's going to last. If someone like Sony decided to ship the PlayStation 5, or whatever they want to call that, with a mouse and a keyboard and a way to plug into a high DPI monitor, if they just supplied an app system, I think Windows as an operating system would be gone. I don't think you'd ever see it again. Forget it. It's a legacy. It's like OS2 or MS-DOS or anything else. Because if you could just buy a relatively fast machine with a consistent hardware platform that has a mouse and a keyboard that plugs into it and you can run apps on it and compile stuff, there's no reason to use this garbage anymore. It is completely unacceptable what they have done to the Windows platform. It is disgusting. It is unusable, and it takes so much more time to actually keep your system running and do anything with it. I have no idea how long consumers are going to put up with this, but I guarantee you they won't. And if you ever gave them any other option to switch to, they will. People aren't stupid, right? The reason they're still using games on Windows is because they don't have another mouse, keyboard, monitor platform where they can compile games and run games. right? Someone else steps in and provides that, Windows is gone tomorrow, period, right? That's it. I mean, they have done such a horrible job with this platform that, you know, I'm not sad to see them go either. They could just, no love lost. They have absolutely treated this platform with nothing but disrespect, and it has been a tremendous burden on the PC community for no reason. So, as far as I'm concerned, my prediction is that if, and it's a big if, anybody wanted to take over games on Windows as a platform, they could do it tomorrow. Sony could do it tomorrow, and it would be over. Because Microsoft provides negative value at this point. Installing Windows on your system and playing games that way is an exercise in futility. It is frustrating, it ruins your gaming experience, and they absolutely don't care. When a version of Windows goes out the door, it is so clear that not a single person who has any power at that company cared one bit what the experience would be for a gamer. Not one bit, because no gamer would ever accept a dialogue box popping up in the middle of a game. It's absurd to even consider. The validation process you have to have in place to allow that kind of thing to go out into the wild. It's ridiculous. Absolutely unacceptable. And I know this is a total rant, but it's an absolutely accurate rant. There is nothing histrionic about this. It is just a fact that the chain of command there does not care about games at all, period. And you can see it, the proof is in the pudding. And the pudding is made largely of dog feces at this point. And that's all I have to say about that. If I remember correctly, SDBu's.lib was used in one of the episodes. Was it for loading PNG assets? No. So what I did, I think it was on Sean Barrett's birthday, actually, is I'd never shown how to use an SDB.lib because we write everything from scratch. So what I did is I made we had a thing that, you know, turned fonts into bitmaps. And I had done that using the Windows API to take the fonts and rasterize them, and then we sucked them out of that and put them into a bitmap, right? And then what I wanted to show was, hey, there's an STB.lib to do that. I think it's called STB TrueType. And so I want to show how to use it. So still to this day, if you go into the test asset processor, there's actually a switch. So right now it's compiled lib-free because, you know, Handmade Hero, we don't use libraries. That's our thing. But you can still, to this day, turn on a thing that will go through Sean's library if you want. And I thought that was important because I do think some libraries are well made, and I wanted to show how to make something, you know, that was... I wanted to show how to use a good library on the stream. So that's the one we did. We didn't use... I don't think we've ever used STB image, which is the one that loads PNGs, but there is a PNG loader in STB lib. What I did do recently, just a couple streams ago, is I tested our PNG reader against Sean's PNG reader because I wanted to see if we were misinterpreting something, and it turned out that we were. We didn't actually ever use that in the game system, but we did run it as a separate, like we compiled it as its own thing and ran it. And that's a pretty handy thing to do. If you have a reasonable code base that does something like PNG reading that you're doing, you can run them side by side to see if you got something wrong, because you know you very well may have, and we had. We were flushing too many bytes in a place. We were flushing one extra byte than we should have, and we learned that by looking at Sean's PNG reader. Since you already have deflate decoder inputted in PNG reader, will you implement deflate compressor for asset files? We could. We'll see. That's kind of we don't care about that right now, but down the line we might. Speaking of stupid driver distributions, Sony only has DualShock 3 drivers for PC packaged with their PS Now software. Ridiculous. DualShock 3 which one is DualShock 3? Is DualShock 3 is DualShock 3 the PlayStation 4 controller? What's the DualShock 3? Sorry, I don't know the DualShock versions. Spent ages struggling with getting the darn controller to work. Okay. My poor friend said when Windows last updated for her, it took 4 hours. Yeah, I'm not surprised. Do you think Linux will take over? That seems unlikely. Also, remember the PlayStation 3 had Linux support. No, I don't think so, because Linux is just as bad. I think you could switch to Linux and have just an equally frustrating experience with Windows, but I don't think that's what's going to woo consumers. You can't really woo consumers by saying, hey, you can be just as frustrated over here as you are over there. Oh, and by the way, there's less games over here. Like, that's not a value add, right? But if someone like Sony actually spent some time making a little desktop and shipped that with a mouse and keyboard, I think they could just annihilate Windows. I don't think they'd have any problem with that, right? There's really not much to it. Windows is almost completely unusable nowadays. I mean, mine barely stays running. And I don't even do anything on this one, right? What would it take to make it more designer friendly to develop on an Ubuntu or Fedora platform first? I mean, I don't really think Linux has a future as a consumer OS. I really don't think so. I mean, I know a lot of people constantly think that it's going to, but it's just not. And the reason for that is you can't have a consumer platform that's inconsistent. The thing about Linux is there's a billion versions of it, right? You try to look for an answer to a question and you find 50 answers to the question, none of which work on your machine. And half of them involve the command line. You know, that's not sustainable. You need a simple, reliable system that people who don't understand computers can use. And I think that's what Linux people don't understand. You need, when you type in something, how do I fix my blah? It needs to come up with one answer, and that answer needs to work, right? It can't come up with 15 answers like, oh, are you on Ubuntu 14.1? Oh, open up the console and then run this command to see how many Ethernet adapters you have. Like, no. An artist isn't going to do that. An accountant isn't going to do that. Only a computer aficionado is going to do that. It's untenable. Linux isn't even anywhere close to being a consumer operating system. It's nowhere close, right? Now that doesn't mean maybe the community couldn't consolidate and say, we're only going to ship one build from now on. Everything's going to be on this build. We're going to simplify everything so you never need to open a console. Sure, maybe. But they haven't done it in 20, 30 years, whatever it's been, since 1992, 10, 11, 14. They haven't done it in 16 years. Why do you think they're going to do it now? MSVC does a terrible job with mod. Let's see here. Someone sent me some Godbolt links. Oh. So I guess it won't do it. Interesting. So maybe we'll have to do and with the -1. Enemy mouse. Are you going to support more complex languages, coding your own Harbuzz text shaping equivalent? No, I think that's probably going to be outside the scope of Handmade Hero. I just don't have the knowledge of that stuff that I would need to do a good job, so we will probably try to keep that sort of thing to a minimum, would be my guess. But I don't know. Maybe we should go the other way and learn it. I don't know. Frosty needed the 6-axis PS3 controller. Ah, yeah. The 6-axis PS3 controllers are much harder to read on Windows due to the way that their initialization procedure works and whether they do wireless or wired. The PS4 controller is very nice. It just pretty much just works when plugged in. So is our plan to infiltrate Microsoft to make Handmade Windows? I don't know. I mean, it's miserable. It's just miserable. I don't understand why they can't just ship a reasonable operating system. And I think it's because they just don't want to. You know, they seem to be preoccupied with all this other stuff. Why is there a 3D Paint program installed by default? You know, why are resources going to these? They can't even ship the operating system part of the operating system. What's all the rest of this garbage? I don't want a new shell. I don't want an edgy Windows interface. I don't care about that stuff. Get that stuff out of here. I don't want JavaScript integrated tiles for my weather report or whatever. Like, that stuff is if you've already shipped an operating system that works. You haven't done that. You shouldn't have anyone working on anything else until you actually can ship the operating system and make it work, which they cannot do, apparently. Oh yeah, and Frosty Ninja, yeah, you need this it's a USB handshake thing that has to happen, yeah. Exactly. For those PS3 controllers. Is it true you can't enable the controller through userland Win32? So you've got to be in kernel mode? Is that basically what happens? Are you sure about that? I guess I don't really know. I've never tried to do that handshake in user mode. All right, looks like the end of the questions. Oh, I realized I forgot a part of that story too, actually. Part of the story of trying to get Anna's computer to work also involved having to unplug the television from it because it wasn't coming up on the monitor. The story I told about was actually a better I didn't even list some of the bugs we had to work around now that I think about it. Too legit to quit. Isn't a big part of the issue that the operating system would need a lot of traction? If Jonathan or someone like you built an OS, it would need a very significant amount of traction to incentivize game developers to build for that platform. It's hard to say. Game developers are pretty used to shipping on lots of platforms right now, so I don't really know that there's that much traction that's the problem. I think more of the problem is just how big of a project it is, right? I think the reason that Linux, Mac, Windows is basically the only games in town now is because it's just a huge undertaking with not a whole lot of upside to it, right? So the only real reason to do it is because it's gotten so bad. So it's like a frustration-based project, you know? And it's just hard to get up enough anger to make that happen, right? So I think that's why. It's like all of these operating systems are garbage. And none of them have their priorities straight. But what are you going to do? It's a massive undertaking to ship an operating system. and it costs a lot of money, and you need a lot of really good people, and you have to do a better job than they did. Otherwise, you're just making a fourth operating system that also is crappy, right? So it's a really big deal, and I don't think traction is probably the biggest problem, oddly enough. I think the biggest problem is really the undertaking. It is a serious undertaking. It is something that requires a lot of dedicated time and energy from several people, and I think that's just a bridge that someday we probably have to cross if we want to save PC computing. But it's a big head of steam that has to get built up there. All right. Thank you, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can follow along with it. If you want to try your hand at writing out those asset things, you can actually do that. If you've got the source code, you can see if you can do it this week. Before I do it, it's probably pretty good practice. While we're at it, we also have a new website. I mentioned this yesterday. I'll keep mentioning it since new people come into the stream. We have a watch page you can go to. It's got the live stream on it when we are live, and the schedule on it when we don't. And of course Twitch ads. But like I said, we don't actually get any money for Twitch ads, so that's just something they insert into the stream. Hopefully, if you're an Amazon Prime customer or whatever else there are, the ads go away. It's also got buttons to hot link to things. And then we also have the episode guide here, maintained by the fabulous Miblo. It allows you to search for stuff. So if you want to see when I'm complaining about Microsoft, for example, you can quickly type that in and see all of the parts of it here and jump right to them, which is pretty awesome. So this is just a great way to catch up on old things or find particular things you wanted to hear me talk about, buried in the archives of Handmade Hero. That's it for this week. Check the watch page for the schedule. I'll be updating it right after this once I check my calendar. So it should say when we're going to be live again. That's about it. Hope everyone has fun programming this week, and I'll see you folks next time. Take it easy, everybody.